is Satyam, and this is day 3 of my interview prep journey. And in this video, we will solve problem around insert node, like the problem called insert node. So in the last video, we solved problem called delete node, where we uh, need to delete a node, right, from a list. Now it's opposite. Now we need to add a node, right? So So basically, this function accept a head of a linked list and the value that for the new node that we need to add, and the index that it uh, it will appear, right, in the node. So basically we need to add our new node to the specify specified index, right? So let's try to think how can we do this. Okay, so let's say we have this example, this list. We need to add let's say index is equal to 2, right? So 0 1 2 we need to add here, right, a new node called, let's say, new. Okay, so the output will be a b new c, right? So first try to understand uh, what do we mean by adding the node in a list, right? So right, at a specific index. Okay, so I think first we need to figure out that uh, that where do we want to add the new node, right? So we need to first let's say the index is 2, so we need to figure out that, okay, uh, which node uh, will have a next node of a new node, right? So yeah, I'll try to solve this problem. Okay, so I know that I need to figure out the index, right? So first, let's say I'll do a normal or or standard way to solve a linked list, or not solve, but standard way to traverse through linked list. Okay, so head, this should be head, and okay, so here we are basically going from head to the leaf node, right, or the last node in our list. Now we need to basically add the code logic. So I need to first create our, let's say, current index, so I can get 0, and every time we traverse we need to update our current index also, right? Now we need to check. So what we will do, right, so the strategy will be, let's say we need to add a new node after D, right? Okay, what we can do is, let's say we will somehow get the somehow uh, get to the D node, right, through our index logic, right, and update the next node to the new node. Okay, and which works fine. Let's say if we want to update in the middle B, what we can do is new node will be the next node of B, and then and the next node of B will be next node of B should have the next node called C, right? So it should be like new C. Now let's try to understand if we need to add on the head or on the first. So how can we do this? uh, Here we are checking for the, I think we need to uh, have some condition here. If index equal to 0, right, which means we will just update our new head, right? So we can create our new node first with same instance value, and we will just update new node dot next equal to head, right? So let's say if you want to if you want to add new node to the first index, right, before A, what I am doing is basically I am creating a node, right, with the same value, and placing it here, basically new. So we have checked it for if we want to add our node in the first place. So this will take care, and we can just return uh, new node. Okay, now let's write for if we want to, let's say if we want to add node um, in between or in the last, right? So yeah, if current equal to index minus y, because we need to check for the previous node, right? So yeah, so current next equal to new node, right, and new node equal to current dot next. This looks fine, and here we can return the or maybe here we can return node, right? Test it, not node, head basically. Your current index should be okay. No, no, no. So new node dot next will be right. It's fine. Okay, ABXCD. Uh, Basically, we have added the X in correct place, but we are not uh, having C and D. Let's think why is that. Okay, so because our current dot next equal to next new node, current dot next equal to new node, right? So we are not getting the old next nodes, right? So what we can do is first store our old node, right? Should be current dot next. Let's think. Yeah, or maybe I can do this like this. New node dot first we can update the no. Current dot next equal to new node, and new node dot next equal to yeah. Now let's test it again, see if we made any changes, see if we made any progress. Okay, it has D but it is not C. Funny. Yeah, yeah. So we have solved this problem. It it took some time to like look for all the cases, but finally we have completed this task. So yeah, bye, thanks for watching the video.